in science classes, we use the metric system for making our measurements and for doing calculations that involve measurements. But if you grew up in the United States, you probably grew up with a different system of measurements called the customary system or the imperial system. So when you learned to measure length, you probably used a ruler that was a foot. And so that would be our base unit in this system would be the foot. And if you wanted to measure something smaller, like maybe you're a little kid and you're measuring a bug, so you wouldn't want to use a foot to measure a bug. Instead, you would want a fraction of a foot. Well, in this system, we divide the foot into twelfths, and each 1/12 is an inch. So it takes 12 inches to make 1 foot. Well, let's say you're measuring something larger now. Maybe you want to measure like the length of your classroom. So you would get your ruler, but you probably don't want to use feet because that's too many feet. So instead you would want a multiplier. So the first multiplier in this system is the yard, which takes a foot and multiplies it times 3. So 1 yard would be 3 feet. That's a bit frustrating because not only are the numbers different, this is a 3 and this is a 12, so it's not even the same number going different directions, but it's got different vocabulary. Foot and inch, they're not even remotely similar to each other, and foot and yard, not similar. So we've got a lot of vocab and a lot of different numbers, and it makes this system really difficult to learn and use. The metric system was designed to be simpler. We still have a length base unit. This one's called the meter. So imagine this is like longer than a ruler. So if you wanted to measure something smaller, then we could use a centimeter. So they took a meter stick and divided it into 100 increments and called that increment a centimeter. And it takes 100 centimeters to make up 1 meter. And that should kind of make sense to us even in the United States because it takes 100 cents to make up $1. So that prefix of cent already kind of means 1/100th to us. So let's say you wanted to measure something larger instead. Let's say you're running a race. Well, you don't want to measure that in meters, so instead there's a multiplier times 1,000 that gives you a kilometer or kilometer. So 1 kilometer is 1,000 meters. This system's a lot easier because we've got that vocab meter in there and we just put a prefix in front of it. Plus, all of the numbers are based on 10. There's no 2s, no 12s, no 3s. It's all based on 10, so it's much simpler. The base units that are the most common in the metric system for length, volume, and mass, length we went over was meter, and the abbreviation for meter is a lowercase m. For volume, like if you're measuring a liquid or a gas, that would be a liter, which is either a lowercase or capital L. I like the capital L. And then for mass, it's the gram, which is a lowercase g. So if you need to measure something that is either larger or smaller than a base unit, then you would put a prefix on that base unit to either multiply it or divide it. So we've got 2 categories of prefixes, the multipliers and the fractions, that would go in front of your base unit. So the multipliers are going to take your base unit and either multiply it by 10 or 100 or 1,000. It's always a power of 10. So you can see 10 to the 1, 10 to the 2, 10 to the 3. They have their own prefix, so you put that prefix in front, abbreviation in front of the abbreviation for the base unit. So let's do example, let's say a hectogram. We would do a lowercase h in front of a lowercase g to mean hectogram, and what that means is we would have 10 to the second grams if we had 1 hectogram. So then on the other end, we've got fractions. If we wanted something smaller than a base unit, then we use the fractions. So the first one would be to divide by 10. The next one we divide it into hundredths. The next one divided into thousands. So you've probably seen milligrams. They're on a lot of nutrition labels. So if you had 1 milligram, so we put the milli in front of gram, if we go down here to the exponents, that is 10 to the negative third grams. It's a very small fraction of a gram. So let's just think about if we were going to make a measurement, what would be the most appropriate combination of base unit and prefix? Well, let's say we're measuring the thickness of a cell phone. Well, that's a length, so the base unit is going to be meter, and then we're going to need a prefix in front of that because a meter stick is way too big for measuring the thickness of a cell phone. I would guess that we would either want to do millimeters or centimeters for measuring a length that small. So let's say we measured it in millimeters, but then we're going to plug it into a formula that requires meters. So now we have to convert within the metric system. Well, it takes 1,000 millimeters to make up 1 meter. So you could make your conversion factor like that, where you put the 1,000 millimeters on top and the 1 meter on bottom, or use the reciprocal of it. Or if you like the exponential version better, then you could say 10 to the negative third meters is 1 millimeter, or 1 millimeter is 10 to the negative third meters. And you just pick whichever one lets you cancel the units in your measurement. So happy converting in the metric system.